Do-do-do. Hi, Shelley.
Hey Mitch, how's it going?
Good. How are you?
I'm okay.
Are you teaching now, or when do you teach? I forgot to ask that last time.
Oh yeah, I teach in the evenings on Tuesdays and Thursdays. Yeah, so now. And
Yeah.
what were you teaching?
Um, when I was a professor,
Yeah.
so I was a professor of mathematics. So pretty much all undergraduate math classes.
Oh really? Oh wow.
Yeah.
Oh good.
It was a lot
Yeah,
of teaching.
no. Yeah. Yeah, you said you had a 4-4?
Yep.
Oh wow. Do you miss it, I guess? Or maybe not the load, but the teaching.
The teaching I do. Um, the pay and the load, not so much. Yeah. I also had three or four research students as well.
Oh really?
Yeah, we had a 2-year required undergraduate research sequence.
Oh wow. I didn't realize. Yeah.
Yeah,
So
so
our
it was
undergraduate math research, is that, I don't know, I would say straightforward or tedious.
and it varies based on project.
Okay.
Yeah, so we would the students would like come to us. They'd like have a class where they would have to go visit several faculty and brainstorm a project and then come up with a proposal. Then we'd just help them through it.
Oh, great. Oh, that's fun. And for undergrads, so my mom actually was a math major and she was a math teacher most of her career. Um, do they have language requirement?
Yeah,
Oh, okay.
yeah, yeah. It was general education type requirements.
Oh, okay. So it's not like I know at Purdue, folks for PhD math had like Russian, French, and
Hmm.
German or some sequence of
Oh,
languages they also had to take.
I see. This was all undergrad.
Oh, okay. Yeah, no, I was wondering in the undergrad level, do they also encourage like as a math major to study a language that is useful for math
Uh,
study?
Foreign language. I mean, I was at St. Edward's University in Austin,
Oh, okay.
so 50% of the students were Hispanic.
Oh, okay. Oh, great.
So most all the students knew Spanish pretty well.
Oh, good, good. Oh, perfect.
I think I
Oh,
had two research students that were American the entire time I
oh,
was there.
oh, okay. Oh, very
Yeah.
interesting.
Yeah.
That's always funny to me, growing up with a mother who studied math and, cousins who study math. I always thought of math as like a pretty girl thing. Like you just need a pencil and paper. You don't have to do anything, you know,
Yeah.
pretty taxing physically. And then to be exposed to the wider world where they're like, oh, math. And I was like, oh, I didn't know that other people have other stereotypes about people who study math.
Yeah. Most of the time they're like, oh, you're a mathematician. I'm like, yeah, and they're like, I hated math. I'm like, I know.
Oh no.
Almost
Oh
every
well,
single time.
Ron wanted me to share with you that he has the code, the MPSG and Julia code up and running, both on our
Oh, wow.
USDA laptop, which is a feat in itself, and on his personal laptop. And
Wow.
then so my plan is to dig in this week or next week, and then the goal is to move farm to Julia, or at least to
Yeah.
try the effort.
Yeah.
And so he also asked, before I forget, when would the next Thursday meeting be?
I think it's this Thursday. I have to send an email about that.
Oh, okay.
Let me look at the calendar. I have to count the Thursdays. Yeah, one, two, three. Yep. I'll send out an email about that one.
Oh, thank you.
Yeah, I was hoping Teams would be easier to use, but I think when you click into this, I think if you clicked into the team, it would take you out of USDA, and that's
That's
just
okay. It does. Well, so when I couldn't get in that one time you shared a link, I've been using that link, but
yeah,
I can use that link still to get in. I think that's when I have to switch to use the chat. And for some
yeah,
reason, it doesn't let me. I have to like pre-plan my entrance if I want to use the chat, I think.
not bad.
Hello. Hey,
Yeah,
May.
just want the teams to be easier to use. Oh, we were discussing teaching a little bit, waiting for
Oh,
people
wow.
to wander in. Yeah, Shelly's teaching right now on Tuesdays and Thursdays.
Yeah.
Very cool. So I should probably say a little bit about what I've been doing. I've been going through a couple of, Ed Balistreri. Guess you both have heard of Ed. He has, let me hit share and then hit a screen. And there we go. Drag you guys over there. Okay, meeting options. You can move too. There we go. The meeting options are always exactly where I want to click stuff. So this page was written by Ed, I think a couple of years ago. Um, and essentially what it is it's a bunch of examples calibrating models for dynamic or calibrating dynamic models. And if you want to get to this, excuse me, I have the hiccups. I linked it here at Illustrator Notes, and it takes you to the same page. This is just the WiNDC website, resources, seminars, and WiNDC Weekly. But he has both a write-up with the actual table and GAMS models that go with it. So what I decided to do is take the GAMS models. The first three I have working no problem. The fourth one, I have a bug and something's wrong. But I'll show you what's happening. Yeah. So let's talk about, I close this model real quick. So this is a social accounting matrix. We've got sectors. I guess we have two sectors and one consumer and commodities in the rows. So what I've done is I took that and just to make sure that, the model makes sense, I have my static data. So that's the Y0, the C0, and the I0. And then a couple other things, LS and KS. I just, for some reason, didn't see those. So I just have a little container that holds that data so that I can make sure it's the same. And then if I look at the model, let me scroll down until I find it. I think it's called scalar model. Static model, here it is. Okay, all I do is I give it one of the data things that I just defined. It extracts those, and then it just sets this up in a model. So it's telling me the output of Y. There's 200 output, and then the inputs are 50, 150. That's what's going on right here. As you can see, it's exactly the same. This is, I guess it's negative LS, but it's an input. LS and KS, LS and KS. Same here and same here. So just verifying that that is good to go. Let me give it some space here. That's exactly what I can do here. You zoom in so other people can see it. Oh, and there's a parse error. Did I do something? Why is there a parse error now? What? Line 27. What did I do? I'm very confused. I literally just ran this code and it worked fine. Oh, there it works fine. I think what I did is I highlighted that. So when you highlight a line in Julia, it runs just that line, which is super convenient. Let me pull up the terminal so you can actually see what I'm talking about, which is super convenient when you're doing something like a long string of things. I can just like hover over that and just call that. All right, so here's my static model. It prints out. You can see it's the exact same thing that I just showed off. Solve it at the benchmark. Very simple model. Set attacks and then solve. And if I wanted to see the values, I could generate a report. Takes a second, probably because I haven't run generate a report before. But there we go. Wait, why is that? Did I not set the tax correctly? Am I not using the tax? No, I set the tax. I'm gonna have to debug that. I wonder why all the values are just going back to defaults. It's a little interesting, right? All right, I'm gonna have to debug that as well because that doesn't feel right. I applied a shock. All right, but that's fine. I'll come back to it later. Now we get to talk about the dynamic stuff because that's stuff we actually care about. So the goal, we need a social accounting matrix for every year. And the question is, how do we make that social accounting matrix for every year? That's what this talks about. The first model pulls the discount rate from the data itself. I will say on Thursday, I'm probably going to go through this in a little bit more detail. I'll just kind of give it a 1,000-yard stare from now. But it's pulling the interest rate out right here. So the RK0, that's the capital stock divided by the capital. So it's kind of like the growth of the capital. And then you just take off the depreciation, and that's what gives you your interest rate. And if you're interested in more detail, we'll go through it more, but I got distracted by a bug in that D4, and it's still in my brain. And then the question is how do quantities grow? So quantities are just going to grow by interest rate. G is the growth rate. And the preferences are going to decay with the interest rate. And if you plug this, and this, so 2, 3, and 4, into PREF, you get that expression, which, if I scroll all the way back up, here I'm holding the data for the dynamic stuff. So there's a lot more. There's these, which are from the static, and then these. And to actually create the data for the first one, this is all you need to input. The time periods and time horizon is determined by these. K0, K0, so doot. RK0, RK0, R, D, here I have it standing for the depreciation rate or delta. PK0 is 1 plus R. Preferences are given by that, given by that. Qref. And in the GMS file, they have R defined a little bit differently, but it doesn't actually matter. So that R sort of cancels out as things go on. And then it just makes my little data structure, so I don't have to worry about what the actual values are. Oops. So when I run this, that D1 data calls that function I just showed off, this guy right here. So I can do stuff like D1 data dot Y0. Let me make this big. Y0 is 200. That's what we expect. Let me push this to the top. So whenever I have a struct, something like this, if I put the struct name, let me move this over so we can see it. If I put the struct name, so I called it D1 data, dot whatever I want, that's what comes out. So I can do qref. So this is how the quantities are going to grow. This is just compound interest, essentially. And I can look at, what's another one? K0. K0 is 500. I guess we put that one in, didn't we? It was, nope, we computed it. Cool, it's right there. So with that, okay, there's 3 scenarios, D1, D2, D3. With that, oh, and I should also say, hold on, one more thing. I have 2 functions called dn1 data or dyn1 data for dynamic. This one and this one. The difference is that this semicolon means everything after it is optional. So I don't have to call anything to do this. I could do dyn1 like that. That's totally cool. But I kind of want my static variables to agree. So I've written a second function that takes the static data. So if I change something here, I don't have to change it anywhere else because it knows what the static data is. And then it just calls the previous function with that stuff broken out. So that's one of the nice features of Julia. Although most languages would be able to do that. And then our actual model is this one right here. Okay. So the difference, here, let me go like this. Let's look at the static model and compare it to the the dynamic scalar model. So there's 2, well, first, I guess there's a lot of extra sectors because you get one for each time period, but there's really only 2 extra sectors, capital and consumption. Those are the only ones that are really new. The price on capital is new. I think that's the only one. Oh, nope, I clicked the wrong one. Price on consumption. PK is right there. Still only one consumer. Still only one consumer. We introduced an auxiliary variable to pin the tail. So I talked about that when we did dynamics before. So that pins the tail. And then the Y block is identical. The I block is almost identical. The big difference being that the output is next year's investment. The demand block is very similar. The big difference being where PL comes from, where PK comes from. Because now PK has 2. It has the beginning and the end. And PL is over all time periods. I highlighted the wrong one. And it grows based on the time period. Cool. So let's see what the results look like. Here, I'm just going to delete. Okay, let's verify that it is calibrated. I'm really hoping that it is because just checked. All right. And then what Ed does in the in his write-up is he checks, or he sets a tax after 2010. So 2010 to the end, I just set a 10% tax. It comes out to solve. Then I've just written a little function that pulls out a report, and that is here. So this is what it's pulling out. It's pulling investment, consumption, capital, and output, and it's just the percent change in those based on the given reference quantity, given the reference growth. Cool. So in GAMS, what they would do, in fact, I can show you what they would do. GAMS. So this is all available on the GitHub. I've uploaded them down to here. So same this. They would use GNU plot. If you don't know what GNU plot is, it's just a plotting package. But it's kind of annoying to get it working on modern systems, especially Windows. Linux would be pretty easy. So Julia just sort of has this built in. I can just plot df1. I want x to be the time, y to be called the values din1, just so I can distinguish them later. And the color is going to be given by the variable. There we go. So you can see 2010, investment took a little nosedive. Oh, this is great for the colorblind. There we go. But if you hover, it says invest, so that's not too bad. But yeah, that's it. And this image is, you can export this as an HTML and include it in a website very easily. So for example, that's what I did. Right here, I wrote a little blog. Come on, there we go. And I'm just exploring what the WiNDC data was talking about. So this is that same type of image. I did it in Julia. You can zoom in. It makes a lot of reporting very easy. And they can get pretty complex if I scroll down to like here. You can include like drop-down menus and stuff. So it makes it easy. Yeah. Where am I going here? There we go. Okay. For the second, so that's the first way to calibrate. Cool. Why did I close that? Should have it over here. Basically, the difference is going to be we're not going to derive the interest rate. What we're going to do is we are going to specify the interest rate. So for this one, we assume that R is given, R is fixed, which allows us to figure out RK0. If I scroll up, you just add both sides. But that creates an imbalance, and the imbalance basically comes, are you going to change investment or capital? So the first example, he changes investment. That's what this is. And then consumption changes because you have to consume less because you're investing. Like there's the difference, or more potentially. And then the capital share is very similar. It just changes capital share. Let me scroll up. One really nice thing is I don't have to change this struct. It's all the same data. It's just assembled slightly differently. So let me close this just so it's a little bigger. Let me give 2. Here is, okay, which one is it? This one. Oh, it's just so simple. Here's DIN1 data, or DIN2. And if I go to 3, there we go. So you can see the big differences here. K0 is defined differently here and here. So in this one, we're adjusting labor and capital. And in this one, we're adjusting investment and consumption. So there's 2 different ways to calibrate this data. And you sort of have to choose which one you want. And I think the big obvious question is what's the difference? All right, because you should expect different numbers because you're adjusting things. So let's check it out. Here I'm doing D2. Notice it's the same model 3 times. I'm not sure if I ran this one all the way through. It's not, doesn't take long, so that's cool. So what I'm going to do, yeah, I think you guys have some understanding of data. I'm just going to take this. I'm going to join them together. So I'm going to take these 3 data frames I just made, join them together, and then stack them. Whoops, I've just pasted something in there. Okay, there we go, cool. Hold on. I right-clicked, and that was apparently the end of everything. There we go. So I want to compare the values. So what I'll do is I'll pull out invest first. And that is how investment changes depending on how you calibrate. So the blue one is the interest rate is implied by the model. The red one, we're changing labor and capital, and here we're changing investment and consumption. So they look similar, right? Investment takes a nosedive because we start taxing it. That's where the tax is on investment. But if I look at output, the third one has a distinctly different trajectory, which I think is interesting. So it's really sensitive to how you're calibrating. Same with consumption. There's 3 distinct horizontal asymptotes. And then same here, which I think is pretty fun. All this code is up on GitHub, by the way. You could pretty easily, you could moderately easily use it. By Thursday, it'll be very nice. Okay. So those are the scalar models, and the scalar models are not too terribly difficult, basing solely on the fact that I was able to figure them out. Let me look at the indexed one. Let me look at this. So the only difference now is that he's moving from a single output to having 2 sectors, 2 additional sectors. Excuse me. So now this is something that we get to incorporate into our model. And the big question becomes, sorry, I have the hiccups suddenly. Great time for it. How do we redistribute? So we're going to do the same thing that we just did, where we redistribute labor and capital. But which sector did the differences go into, or how do you make that split? So what Ed proposes is just simple least squares, holding some things to be fixed, capital demand and labor demand. So glossing over the details pretty severely. I set up a struct for my index data because they'll be a little different because I need to hold my X and like labor demand and capital demand stuff. And then right here is the little optimization model. So if you're not familiar with JUMP, you can probably read this just fine. I make a model called M. I make 2 variables that have lower bounds, one for capital earnings, one for labor earnings. The objective function, we're trying to minimize it. Least squares. 2 constraints, one called VA balance that iterates over the goods. So it's just making sure each good is balanced. And then capital balance. And then it optimizes and pulls out those 2.
Mitch, I apologize. I have to hop to another meeting, but I will finish watching this video. This is really cool.
Yeah. That's
See you next week. Thank you.
Yep. How's it going, May? It's just the 2 of us. Oh, you're muted, by the way.
Yeah, keep going. I'm following.
Oh, cool. Yeah, I taught online during COVID, and I would usually say something like, "All right, everybody, just stay muted if you understand it perfectly." Awesome. Let's keep moving. Yeah. Yep. So I just make my index data. Um, and then same thing with the static data, just so I can have one place to change things instead of two. And then the actual model. So here's where I'm having trouble. Somewhere in this model, I have an error, but I don't think I have an error. I think something else is happening. So let me show you what's happening. Let me scroll up and just make sure that I run all of this code. So when I run index data, notice that I get IPOPT output or IP opt output. That's because it's running that calibration routine. So it's expected. That's good. I pop it into my model. Takes a second because it's fairly large. I put a semicolon here. Let me show you why I put a semicolon here. So here's what it looks like with a semicolon. Here's what the terminal output looks like. Nothing. Take off the semicolon. Oh, it actually didn't print that much. It's a lot more output because it's printing the model. So like it prints all these little production things. I really don't need that. It's just a simple. But I prefer the semicolon because I don't need all that. Are you ready to see the problem? I swear, if this had been 0, I would have been very upset. So the problem is it's not balanced, and I'm not sure why. I can show you a couple things. Yeah, so I can show a couple of things. So the first thing I always check is I check the report, and then I sort it by the marginal value. So that's the first place I would start looking. That's K sector. And this may just be important because, or this may be useful because then you can see how my brain works debugging these things. And I look at the report, sort it by margin, and I look for one of them that's a sector because the sectors are easier to debug. And what it's saying is, so K0, this one is unbalanced. It's off by like 1.22. So there's a couple things I want to check. You don't necessarily expect these numbers to add up. Here, let me show these. So there's one thing that we're doing that makes this a little bit weird, because typically you would want I don't want to keep writing B4 data. Hold on, let me do this. Let me look at K so I can actually get this right. Do K0 equals D4 data dot K0. K0. Come on, AI, one more. So what you kind of expect is I guess I can just type it out. You expect K0. So both elasticities are 0. I'm going to scroll down so they're all on the same line. So you expect K0 times the value of P, I guess it's P4 model, PK 2001. And then I need a 1 minus D plus, where is it? KS0. So this is the output side. Elasticities are 0, so it makes it pretty easy. And then the input side would be K0 times the value of that. And as you see, these two they're not the same. So somewhere I have a bug or some logical issue, and I don't quite know what's going on. Another thing I like to do is I want to look at the actual zero profit function. So I take that sector, that's D4 model K. That's just how I'm extracting the K at the year 2000. And here's what it looks like. Let me close this for now. Which is essentially what I've just typed here. As you can see, this is K0 times PK. And then because this power is 1, this gets pushed through and it becomes exactly that. And I'm not quite sure. Let me do one last thing. The other thing that could go wrong, that's not the right thing. I need this one. Another thing that could go wrong, and you're probably going to ask, are your numbers the same as the ones that he has in his GAMs?
Yeah.
Yes. Unfortunately. Everything. Let me go. Here we go. K0, 500, 500. Let's go RK0 for data.rk0. 0.726, 0.7073. It's just not resolving low enough. R 0.05, 0.05. PK0, 1.05. KS cal is KS0. So the numbers are all the same.
What about the 527, 526?
Which one?
The one.
Oh, these ones.
Yeah.
Yep, that's a good question. You're not going to like my answer. Right here, 105, 58. And then the other one, KD equals 14.5, 21.789. So yeah, unfortunately.
I mean, can we match the whatever the 527, 526 that the mismatch in between, like from the GAMs?
Doing this and this.
Yeah, can we report the same thing to see it?
It would come out to be 0. Because in the benchmark, here, let me go. This is 4. This is 1. I don't want 1. I want 4. There it is. Okay, so it is exiting after the benchmark. So all these are benchmark values, which is great. Find var k. Yeah, there's the marginal value. How can I get out? I'm not totally certain how I extract that from GAMS. But I'm fairly certain. This. So both of these are K. These numbers line up. Okay, mine jumps a few, but I believe, yeah, they're going to line up because it's the same calculation. And yeah, so all the numbers going into it are the same, but I'm getting a different result. I might also send Ed an email with this question because it could be something in MPSGE. It's doing something weird, but that doesn't feel right. And I can look at.
What
Sorry, go
about
for it.
variable PK?
Yeah, let's look at.
The listing file.
So at the benchmark, this is going to be PREF. Let me find. This one has
It's
more
not, it's not
zeros.
yeah, yeah, the PK needs to be explicitly defined. So if you go to the GAMS, and you see that after the end of the program, there is a PK being defined, which is not QREF.
Let's see here.
Yeah,
It's this, right?
yeah.
I do have that. Let me scroll to here. That's right here. I misspoke. I'm at PREF and PREF times PK0. Although looking at them, the numbers are slightly different. So that's interesting. The first number is the same. Okay.
Oh, the second number deviates.
Right. So let's look at PREF. Aha. Yep. PREF is slightly different. How does he define PREF? Huh? That's the same because it's 1 minus R, and we checked that R was the same, right? Back here, you know what? I'll just do it down here. R. Okay. So what do we expect this to be? We expect it to be 1 minus R raised to the 2000 to 2101. Oops, that's not going to work. We have a dot. I mean, that looks, oh no, that's because it's not this. It is 1 to minus 1. Okay, they're off by 1, but that's fine. It would really be 0 to insert is off. That's the problem. Yeah, this looks better.
Okay.
So why? What am I looking for here? Ah, that would do it.
Yeah.
Interesting. Minus.
That's a different way, yeah, it's a different way of calculating this decay.
Hey, now it's calibrated. May you're a
Great.
lifesaver.
Good job.
Yeah, I don't think I've ever actually debugged a model like that on recording. So that's good. It's very quite good. That's okay. I gotta check one more thing. Let me scroll up. There's where the mistake came from.
Yeah.
Interestingly,
But I would apply the way that you did. But anyway, that both would they're probably introducing something different.
interesting. So here's the interesting part. For the scalar model, it doesn't actually matter. It doesn't appear to matter at all. I wonder if I change this. So this is the scalar. This is Dyne1 data. So minus case. Go back up to here. Okay, let's see if this is still. Yep. Oh no, it's not. How bizarre.
That affect the definition of the PK in the beginning.
Yeah.
Yeah, so and it needs to match.
Yeah. Interesting. So I'm looking, oops, at this guy. Interesting. Because that was one of the issues that I had, right?
Yeah.
In this document he writes up, he has it like this. In GAMS, he has it like this.
But then yeah, so so guess because
Yeah.
the PK is being defined with PK 0 equals to 1 over 1
Yeah.
minus R. So that that needs to be consistent.
Interesting.
Yeah.
I see. So PREF is really 1 over PK 0 to the T.
Yeah.
That makes
Yeah.
sense. I'll just write PK raised to the minus T. That one, PK 0. Okay,
Great.
cool. Yeah, because he also has R defined differently. So here he has R defined like this. Oh, that's great. I can ask May questions. Here he has it defined like this, which is really, based on what he has, it's 1 over 1 plus R. So using this R, that's what this is. And I'm assuming that affects PK 0.
Yeah.
But I don't know how. I'm guessing PK 0 is, I guess it's 1 over 1 minus R. I guess I could plug that in there and just sort of figure it out, but
Yeah.
I also really don't like that GAMS is case insensitive.
Yes.
I find it annoying. All right, cool. Well, I'm very happy I got that little bug fixed because now I don't have to bother Ed. Because he'd have been like, yeah, you moron. You
So
have a
now you can
typo."
move on to 5.
5 should actually be pretty easy. Here, let's look at it. In fact, where is? I think I use Google like a millennial uses Google, which means everything I go to, I just type it into Google and then go there. And I have a feeling that's what Gen Alpha is going to make fun of me for when I'm old. Okay. So my guess is that the model is exactly the same. Oh no, it's slightly different. All right, it'll be a little bit more work done. Oh, and he makes it be a different model. Oh, that's great. Good show, Ed. Oh, the difference between 4 and 5 is that here in 4, I scroll up, we are assuming that the growth rate is the same for every year, that the depreciation rate is the same for every year. I think the big difference, he's still assuming it's the same. Yeah, I'll have to go through that. I was hoping it'd be easier. Mainly because once I wrote for number 1, it was very easy because all I had to do was change the input data. Which is what I'm going to do for this one. I just can't do it right away. Oh, that's a shame. They look at it. See, but it has all the same stuff in it, right?
Yeah.
The model to calculate the changes. So all that's going to be the same. The big difference is adding these things.
Oh,
What
it's
does that
just he does the sexual
Yeah.
productivity adjustment.
Yep. Right here.
Right.
And I'm guessing down below. Yeah, then he does a shock and makes it be not.
Yeah.
Okay, that won't be too hard to implement. In fact, if I just say that's always 1, yeah, if I just eliminate this part and say this is always 1, I think that could eliminate that sector completely. Where does PKG feed in? Oh, maybe not. RK, actually, yeah. Now let me look at this. Let me look at the actual model that I've written here. Do you think of these things like little trees? I think of these things like little trees. Because this one, did I turn on annotate? Am I drawing? There we go. Okay. This KJ, okay. Oh, annotations aren't going to work because why does it keep? Ah, wonderful.
Mhm.
I dislike Teams. So there we go. There's only one output, so I could replace that output everywhere with this, right? So I could eliminate that just by putting this as RK of T. Yeah, I can fill in the rest. And that effectively replaces this completely. And then where's the other one? There it is. Then I have to get rid of this. Okay. But yeah, I won't do that quite yet, just so don't break everything too bad. But yeah, I'll have that ready for Thursday. And I'll upload this GitHub.
That's great. So Thursday you're going to talk about this.
Yep.
The monthly meeting. Good.
Yep, and I'll go through it in more detail. Although I should ask, do you want more Julia stuff or more like MPSGE dynamic stuff?
More Julia stuff.
Okay, good. Yeah, I always have to remember to ask you guys what you want to see because otherwise I'll just talk about nothing.
I can't speak for everyone, but I definitely need more Julia stuff.
Yeah, okay, I can do that. Yeah, I think next week I'm going to really push to get some of the more state disaggregation done. So I'll try to talk about that next week.
Great.
Yeah, because that's going to be cool. Tom has a gravity model that I've implemented for the make use framework for a thing with a ERS. But it should be pretty easy to translate it to the supply use framework. Because then we could have we could disaggregate trade flows by state to state.
Is that what Advelature is working with Tom on?
Yeah. Like
and then they're going to have a GTAB seminar on it the end of next month.
Maybe I'll have to I'll ask Ed about it.
Sure. Yeah, I think that's there's an email coming in. It's about GTAB, the GTAB virtual seminar, October 28th or 26th. It's on Tuesday.
Oh, cool.
Okay, looking forward to it.
Yeah. Is it iceberg trade flows disaggregating to the?
I think I only glimpsed the title is the trade disruption. I guess that's.
Oh, yeah. Ed has a lot on that. Yep. He gave a talk about that last year at Madison. It's very interesting. I think he called it.
Forward.
I think he called it terrifying.
Terrifying.
Yeah. He's got a good dad sense of humor. All right, cool. I'll prepare more Julia stuff, more models and more stuff and just keep pushing stuff up.
Nice.
Cool.
Do you have any plan after after doing all of these, converting all of these MPSG examples into Julia?
I mean, there's always going to be more examples, but a big
Right.
reason that I'm doing it is because I need to prove that MPSGE in Julia works as well as it does in GAMS. Because I think that's what people want. They want reassurance that it works. And then I need to work on the documentation for MPSGE.
Right.
And all the WiNDC stuff, can finish the conversion of WiNDC into Julia. Just make it easier to use.
That's
But
great.
I have a few ideas after that, but I don't want to promise and then have it not happen.
Really. It's a lot to do.
Yeah.
All right.
All right. Cool. Thanks for coming.
Thank you, Mitch.
Yep. All right.
All right. See you on Thursday.